Go.
Alright, next
Explain
part
what you're doing.
in your unit is 8.3, and then this is where you start getting into holes and stuff like that. So what is the primary difference you notice between the last paper you did and this one?
There's a lot more going on.
Right, yeah, there's a lot more going on, there's parentheses, all that stuff. Right, so really it's not as bad as you think, because all you're doing is reading it. I don't know why it's
Ooh, it's
yellow.
yellow.
It doesn't look that bad
Um,
on the camera.
The last
Okay.
time I said it was yellow, she said it
So
was high.
the ones at the bottom are going to be your vertical asymptotes. Like now, instead of having just one, you're going to have multiple ones where it's going to be like, I don't know, you're going to have a set of graphs and it's just going to look like there's borders going around it. So when you have a number in parentheses with x, right, it's the opposite value. So if this is x minus 1, it's going to be plus 1, right, when you change it. So that's what your vertical asymptote is going to be. It's going to be x plus 1, or x equals positive 1, sorry.
It's okay, Nick, I forgive you.
And then the other one is just going to be x minus 2. Alright, your domain is just going to be like the same like the other ones, like whatever you get for your asymptote is what the domain can't be. So it's going to equal all real numbers. And x cannot equal
1 or negative
1, right, or negative 2. We're not going to do your horizontal asymptote right now because that takes a lot more time and Claudia said she was probably going to do it tomorrow. It's kind of time consuming. And then I'll explain holes in a second when we get to the next one, but for this one you're going to put none. Okay. So now you're at this one. So what do you notice about this and this?
2. The top one has 1.
Oh, you can reduce it.
Yeah, that's right. So if it's on the bottom, you can take it up from the top. But before I get to that, what are the two vertical asymptotes that you have at the bottom? So if this is a plus 4 and a positive 3, x is going to equal what?
Negative 4 or negative 3.
Right. Okay. So before I write the domain, now you have these, right? And you said you could cancel them out, right? So this is what a hole is. When you have the same thing in the numerator and the denominator, the same number of times, right? Then you can cancel it out. If it's like, hold on, like number 6 over here, where you have this, there isn't a hole because those, even though these cancel out, you're still going to have this x plus 3 over here, right? So that's not going to be a hole. Do you understand that kind of, or no?
Yeah.
Okay. So then your hole for this one, you're going to say negative 3. This is the kind of the part I don't understand this audio. How do you
Plug negative 3 into, after you reduced it, what's left? Write the equation y equals 2 over x plus 4. So you're going to cross out negative 3 with your vertical asymptote.
Oh.
Cross that out. And now plug negative 3 into that simplified function. So put an x equals negative 3 into y equals 2 over x plus 4.
Okay.
So to find the whole, you're going to plug negative 3 in for x and evaluate it. What do you get? What's 2 over negative 3 plus 4? 2.
2 over 1, right, so 2.
So 2. So negative 3, 2 is a whole.
So then you're going to put whatever the value you get after plugging it in is going to be the value over here for your hole. And then because you've canceled out the vertical asymptote of negative 3 over here, you've listed it already as a whole. Instead of putting it in the domain, you're just going to put x cannot equal negative 4 because it's all that you have left over here. Right, all real numbers, x cannot equal negative 4. Right, for this one, who knows how to get a vertical asymptote? Who can name one for me?
3, -1.
Wait, one more time?
X is -1 and X is 3.
Right. Do you want them separate, or can you just list it as kind of?
I usually write them separate, but that's okay.
Alright, so, like I said, I don't know if this helps, but when you're doing it, the vertical asymptotes in the domain are directly linked. So if you scroll a little arrow right there, I don't know if you did it in my class, and it kinda helped us understand it a little bit better. And then, is there a hole in this equation? Is there anything on the bottom that repeats on the top? No.
So there's no hole.
And your domain will be just like the other ones, will be all real numbers, but x cannot equal -1, and x cannot equal 3. Just like that. Are you taking?
No, you're doing it.
Okay.
You're doing good. You're doing good.
Alright. So, is there a hole in this one?
Yes.
Right, because there's an x plus 2 on the bottom, and there's an x plus 2 on the top. Normally when naming the vertical asymptotes, you put both of these at the bottom, but because we know it's going to be a hole, we're going to leave that away from the vertical asymptote, and we're going to put it in the hole instead. So the only vertical asymptote left is what?
X equals -4.
-4. Okay, so this is your hole now. Your first value is going to be -2, right? Okay, so if I were to now plug this in over here, after changing the equation, it's going to be y equals x minus 1 over x plus 4. So now I'm taking that -2 that I got over here, right, or that I'm taking out from here, and I'm plugging it in for the value of x. So instead of it having an x minus 1, x plus -4, it's going to be -2 minus 1, and then -2 plus 4. So after doing that, that'll equal -3 halves, or if you like to write it as a decimal, it'd be -1.5. Right, so now that we've cleared that up, the only one left for the domain is going to be -4.
Now, when you do the domain on this one, you should also include, you should say all real numbers except -4 and -2.
Okay,
That's why, remember in class I crossed it out, but you still
okay,
include it in your domain. All real numbers, x cannot be -4, and x cannot be -2. Because that's what the hole is.
right.
It's saying you can't have a point at -2, so you have to include it in your domain. So that other one that you had a hole, I think you missed that one too.
Oh,
Yeah, that one you should write x equals -4, all real numbers x equals and it can't be -3, you got a hole there. You
Right.
can't plug -3 in for x,
Do you
because there's,
still have that picture that you drew? Because I didn't know how to explain to them
I'll show
what
it to
all
them,
looked like.
I'll show it to them, yeah. We're gonna be graphing these tomorrow, so.
Okay. Alright, so now you move on to this one, and this one's also gonna have a hole, right? Because we have an x plus 2 in the denominator and 1 in the numerator. So it's not like y equals x minus 2, x minus 1.
Good,
Right.
raise your paper a little bit.
Oh, sorry. Okay. In the vertical asymptote, which one is left? It's that x minus 1, right? So x is gonna equal 1. Okay, so you do have a hole in this one. So now instead of having that, the hole is a -2, like before. It's a +2, then you flip the sign, it's a -2. You're going to plug this -2 in for x. -2 equal which is, yeah. Because the two negatives will cancel out. Alright, so this is the value that you're gonna plug in over here in the hole, so -2 and then 5/3. And for this one, the domain that you have left is all real numbers. That's not equal one, and then, yeah.
Good.
But you don't have that on your key either.
I don't? Okay, it needs to be there.
Okay, and this last one, does anyone remember what I said about this one? Is it gonna have a hole or not? You think it's gonna have a hole? Alright, well, let me explain it a little better. So if, these are all the same, right? Just x plus 3, x plus 3, x plus 3. Okay, well, if you cancel these out, you're still gonna have this one there.
Oh.
So it's still gonna be x plus 3. So after rewriting it, sorry. Plus 3, just like that, sorry, it's a little. Just like that. Okay, so, does anyone know what the vertical asymptote will be over here? -3. You have the positive 3 over here, you flip the sign, and then this is what you're gonna get. Okay, so we said that there's not gonna be a hole there. So we're gonna write none. And then the one left, right, from your vertical asymptote to the domain, your domain will be all real numbers. So x not equal -3. Does anyone have any questions, like clarifying anything? Yeah.
Do we just leave these out?
Yeah.
We're gonna do them tomorrow. It's gonna take me about 15 minutes to explain all the different kinds of horizontal asymptotes. And so we'll save it for tomorrow. It's gonna take a couple days to teach you.
Are we gonna have homework tonight?
He's gonna flip it, we're doing it right now. We're doing it right now.
So really, it's just 6 problems. So what is the difference in form between these and these?
The other
Those
ones
ones
were
are
factored.
factored.
Right, these are in factored form. So, I know, it all kind of leads back to factoring. But when you look at it, it's really not as bad. It's not like you have like a 15 here and then you have to like guess and check. Like there's one of them like that over here, but this one you can GCF and you can take out a 2 in that one. So it's really not as bad. So what are 2 numbers that you'll get when you multiply to get 8 but add to get 4? Or to get 6, actually, just gave you one of them.
4 and 2.
4 and 2. And what about 1 to add up 5 but multiply to get 4?
4 and 1.
4 and 1. Alright, so now this one looks like the ones on this side. So, is there a hole in this one? Are there any of them that are repeating?
Yeah.
Right, the x plus 4. You can cancel those out. So really, it's gonna look like y equals x plus 2 over x plus 1. Alright, so you canceled those out. Just make sure I'm doing everything right. Oh, actually I think I did something wrong. Because there isn't a hole on this one. I think I factored these incorrectly.
No, but I did the
That's right.
same one.
You're
Then why
right.
does it say no over here?
Let's see.
I think you factored incorrectly.
Let's see. Oh, I hit it. Oh, because I had a different problem.
Oh,
This is not the right key.
okay.
This is not the right key. You're good.
Throw me off.
Well,
with
I
something.
think convenient.
Alright. So you have x plus 1 at the bottom, right, after taking out that x plus 4. So what's the vertical asymptote? Just the opposite of positive 1, which is negative 1. Alright, okay. There's a hole in this one, in the first value. So that -4. Oh, sorry, I need to close that parenthesis here. And how do I find this value over here? Right.
Plug it in.
Maybe
So,
write this space up here. So you have x plus 2 is supposed to be negative 4 plus 2 over negative 4 plus 1. Okay, this is equal negative 2 over negative 3, or 2/3.
yep.
Just like that. Going to the domain. It's going to be all real numbers, but x cannot equal -1. And then we're going to add it at the bottom as well, just like on the other side. X can also not equal -4. Just like that. Alright, the next one, this one's already set up for you. It's not like you have to factor that one out. But what can you add up to get 4 and then multiply to get 3?
3 and 1.
3 and 1. Good job. Okay. So I'm going to rewrite it. Equal x minus 5. Is there a hole in this one? No. So you're going to hole right none. Your vertical asymptotes, which are the two at the bottom, x is going to equal what?
Negative 3 and negative 4.
Negative 4?
Well, negative 1.
Negative 1.
Negative 3 and negative 1.
Right. Just like that, on the domain. All real numbers. X cannot equal -3, x cannot equal -1. Just like that. Alright. Now we're going to factor this one. Does anyone know if this is factored? 8x, what multiplies to get 15 and x to get 8? 5 and 3. X plus 5. X plus 3. What about this one? What do you add to get 5 and multiply to get to 6? 2 and 3. Right. There will be a hole in this one because the x plus 3 repeats in both the numerator and the denominator. We're going to cancel that out. We'll rewrite it as well. Should we write it? Y is equal x plus 5 over x plus 2. Okay. So we move over to your hole, because you know there's going to be one, because x plus 3 canceled out. So it'll be the -3. Right. After now plug -3 in to this equation after taking x plus 3 out. Do you have a scrap piece of paper?
Under here. Yeah.
Oh. Alright.
Got right on line.
Okay. So your y equals the value we're going to use is your -3. So we put -3 plus 5, -3 plus 2 is equal to this is going to equal -2. So you found your value for that. You're going to go back to the hole. You're going to put -2. Right, after we solve that, the vertical asymptote, what's left is the x plus 2, which is going to give you an x equals -2. For your domain, just like the ones before it, all real numbers. X cannot equal -2, and then for the -3 for the whole, x cannot equal -3.
2 more.
3 more.
3 more?
Sorry, I'm trying to get detail. Okay. So this one is different because you now have a number or a coefficient with that x, but it's something that you can GCS. So if you were to take a 2 out of there, what would you get?
X squared plus 4x minus 5.
Minus 5. Okay. And then if you were to factor the bottom, hold
X
X
plus
plus
5,
five,
X
X
plus
plus
5.
on. Right. I actually forgot how you did this one for the top.
Well, factor x squared plus 4x minus 5. It factors to be x plus 5, x minus 1.
Okay, so I'm doing that again.
Yeah,
So,
you're gonna just
okay.
factor that trinomial.
Alright, so this one is
X plus 5, x plus 5. And then that top factors to be 2,
so what, you have the 2x squared plus 4x minus 5. Then you're gonna break this down again, so it's
2, and then x plus 5, and x minus 1. Over x plus 5, x plus 5. No hole.
And why is there no hole? Anyone?
Because they repeat.
3.
Right, there's 3 of them, so if there's an even number, they're gonna cancel out. But you're still gonna have 1x plus 5 remaining at the bottom. So if this is your equation now, what's your vertical asymptote if on the bottom you get x plus 5,
X minus 5.
right?
X equals negative 5. No hole in all real numbers except x can't be negative 5.
Alright,
Can you go fast?
can I go fast?
Yep.
Okay.
Super fast.
Alright. Y equals, what is this factored?
X plus 2, x plus 1. Is there a hole? Nope. What's the vertical asymptote?
It's a
X
negative 1 here,
equals
so it's a positive
1.
1 here.
So all real numbers, x can't be 1.
1.
Last
That's
one.
What is this factored in 1?
How do you factor x squared minus 5x plus 6? X minus 3, x minus 2.
Yeah, x minus 2, x minus 3.
Same thing. Then x minus 3, x minus 1. Is there a hole?
Yes.
Yes, at 3 what? Anyone get the hole?
Negative 3, 5 fourths.
5 fourths?
Yeah.
It's 1 half.
I got, yeah, that's one.
It's 1 half.
You have negative 1 here, so you can just go on to 1, and then your domain is all real numbers.
All real numbers, x can't be 1 or what? 3. Or 3.
Miss Audrey, I think.
Nice job. What's that?